So we looked at the working of OpAmp as a non-inverting amplifier.
The output of that configuration was in phase with the input, but for some application, we need the output to be 180 out of phase with the input. So in this video, let's learn how to make an inverting amplifier. This is Abhinav from learnelectronicsindia.com, and let's get started. Let's first have our LM741 IC with plus 12 volt and minus 12 volt as the supply voltages. Now let's connect a feedback resistance between the inverting input and the output and connect a resistance to the inverting input. Now let's ground the non-inverting input. Let's have RF to be 2 kilo ohms and R1 as 1 kilo ohm. For the sake of explanation, let's give 1 volt DC supply and place voltage and current probes before R1, after R1 and after RF. So now let's run the simulation and observe the output. The voltage across R1 is 1 volt and the current flowing through it is 1 milliampere. The voltage at the non-inverting input is 0 as it is grounded, hence by the principle of virtual short, the voltage at inverting terminal is also 0 and no current flows through the OpAmp. Hence, the entire 1 milliampere current flows through the resistance RF. This creates a potential drop across the resistor, which is given by Ohm's law. Hence, V is equal to 2 volts. As the inverting input is at 0 volt, the output must be minus 2 volts to make the potential difference as 2 volt. Thus, the input signal is amplified by a factor of 2. This amplification factor is given by the ratio of minus RF by R1. The negative sign indicates the output signal is 180 out of phase with the input.
Now we will connect a function generator to the inverting input of the OpAmp. We will take an oscilloscope and connect channel A to the input and channel B to the output of the OpAmp and observe the waveform. As you can observe in the waveform, the input voltage oscillates between minus 1 and 1 volt. Output voltage oscillates between minus 2 and 2 volts, and the output waveform is 180 out of phase with the input waveform. You can repeat this by using square wave and check the output. Such inverting amplifiers are most widely used in oscillator circuits to satisfy Barkhausen's criteria to produce sustained oscillations. You can find detailed instruction along with the circuit diagram at our website link in the description. This is Abhinav from learnelectronicsindia.com, and thanks for watching.